Well, we have a question here. The question says the first four terms of a quadratic pattern, number pattern are -1, x, 3, and x plus 1. Now, okay, we're going to do question 3.1.1. The question says calculate the value of x. Well, I'm right here, 3.1.1. So we're looking for x here. Okay, and then it did say that the pattern are quadratic pattern. So on the right, they are like -1, x, 3, and then x plus 8. Okay, because it is a quadratic pattern, we have some property for quadratic pattern. We do know that it has a constant. The second difference is constant. Okay, so we're gonna calculate the difference between this and that, that and that, and that and that. So x minus x1, x minus 1. So like x minus 1. And then there we have like 3 minus x. And then over here, it's going to be x plus 8 minus 3. Now this makes what? X plus 1. And then this x plus 1. And then over here we have like 3 minus x. And then there we have like x plus 5. Now this is the first difference. Now the second difference must be 3 minus x plus 1. And then over here it's x plus 5 minus 3 minus x. So if you work it out, that makes 3 minus x minus x, and then minus 1. Over here it makes x plus 5 minus 3 plus x. Now we have like x, negative x and negative x makes negative 2x, and then 3 and negative 1 here makes plus 2, and then x and x here makes 2x, and then these two also makes plus 2. So now it is proven that the two are equal. So it is not proven, but we're going to set the two equal because the question itself says it's a quadratic pattern. We know the condition is that the second difference, the two must be constants. So we're gonna set the two equal. So we're gonna do we're gonna move this negative 2x over and the positive 2 over. So we have like 0 over equal to 2x plus 2 plus 2x and then minus 2. And then we have 2x and 2x makes 4x. And then 2 and 2, that's false. So now if 4x equal to 0, this means that x is equal to 0. Okay, if you're unsure, sum x 0 or divide both sides by 4, and then you get x is equal to 0. Now, the following question says what? If x is equal to 0, determine the position of the first term in the quadratic number pattern for which, excuse me, the sum of the first differences will be greater than 250. All right, okay, I'm gonna move. Let me read the question over again. If x is equal to 0, excuse me, determine the position of the first term in the quadratic number pattern for which the sum of the first differences will be greater than 250. Okay, now I'm gonna write my question over here. It's question 3.1.2 now. Already, okay, it is given that x is equal to 0. Therefore, the pattern can then be written like -1, 0, 3, and then 8. Okay. Now it is said that if x is equal to 0, like over here, we need to determine the position of the first term in the quadratic number pattern for which the sum of the first n term, the first difference will be greater than 250. Now, by definition, we do know that Sn equal to n over 2. Okay. 2a plus n minus 1 times d. Now we can substitute the value the values here of a, okay, because the first term here is will be of the first difference here is will be then, because x is 0 over here, x is 0 now, so the first difference is going to be 1, and then this will be just, we submit 1 over there, and then that makes plus n minus 1 times the difference now is because x is 0, the difference will be, so we can check here. So we're like x is 0, so we're like the pattern is now like 1, 3, and then 5. So the difference obviously is 2, the constant difference. So it times by 2 there. And then this makes what Sn will be equal to n over 2 times 2 plus 2n minus 1. Okay. If we times n over 2, there we have like n over 2 times 2 plus n over 2 times 2n minus 1. Okay. And this will make, we cross the 2 out, we cross this 2 out, and now this will become 2n plus 2n times n minus 1. And this makes 2n plus 2n squared minus 2n. And 2n and 2n falls, and then we're left with 2n squared. Now the sum here is 250. So it's now 250, as the question says. We can work out the value of, I can move this over. And then this means that if I divide by 2 both sides, that makes 125 is just equal to n squared, or n squared equal to 125. Now to work out n, I'll square root both sides to find the values of n, square root here, square root there. And then obviously this gives me plus minus values. If we do a square root of 125, this is equal to 5 root 5, which is equivalent to oh, I mean 250 divided by what did I get here? Okay, I got that 250 divided by, well, over here it's we did simplify to 2. I think, yeah, it's a mistake here. This is like, there's not 2 there because it was simplified over here. We crossed this 2, we left with n only. So there's no 2 here. There's nothing here. So this makes plus n. So n squared was equal to, is equal to 250 only. So that makes, we have like n squared equal to 250. So if we need to find n, we can just square root both sides. And then n will be equal to plus minus square root of 1 over 250 is 5 root 10. If you press SD, we get plus minus. So okay, it's plus minus 15.81. But remember, n is a term, so the negative solution cannot be accepted. So this is just 15.81. Then the fact that we got this is not the answer. All we can do, all we can say, the sum of the values must be 16, because n cannot be must be, I will say n will be equal to 16. Those are the values, because it must supposed to be greater than that number actually. So we actually wanted something that will be greater than that's greater than this. Yes. So n will be, so the sum of the 60 first difference will be greater than 250. So if we sum the first 16 values terms, it will be greater than 250, as we said. Thank you.